welcome to True Projects. In this video, we are going to explain about the project which is Bangla Natural Language Processing, a comprehensive analysis of classical, machine learning and deep learning based models. Introduction. With 265 million speakers, both native and non-native, Bengali ranks as the 7th most widely spoken language globally. In today's digital age, access to online resources and technical knowledge is vital for personal and professional growth. However, English dominates these domains, creating a language barrier for Bangla-speaking individuals who may have limited proficiency in English. The project focuses on advancing the field of Bangla natural language processing and addressing crucial needs within the Bangla-speaking community. The project employs a wide range of approaches including classical techniques, machine learning methods, and deep learning models to assess their effectiveness in BNLP tasks. The project provides insights into the state of BNLP, including its limitations, current and future trends. Additionally, it seeks to facilitate improved access to Bangla language resources and technology for a broader audience. Objective. The main objective of this project is to narrow the language barrier, facilitating improved access to online and technical resources for individuals who are primarily speak Bangla. The project employs a variety of algorithms including classical techniques, machine learning models such as logistic regression, random forest, ADA boost, etc., and deep learning methods like RNN with LSTM and CNN. These algorithms are strategically utilized to process and analyze Bangla language data. Classical techniques provide a foundation, while machine learning models offer data-driven insights and deep learning models excel at handling complex linguistic patterns. Their collective use allows for effective Bangla natural language processing. The project aims to empower Bangla speakers by enhancing their digital literacy and improving access to online resources through advancements in Bangla natural language processing tools and techniques. For implementing this project, we need hardware and software requirements. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. In software requirements, we need Anaconda 3 and Visual Studio Community version. In the flow of work, we have designed few modules to implement the project. The first one is importing the packages. This module involves importing the necessary libraries and packages for project's execution. We have imported NumPy for numerical operations, Pandas for data manipulation, TensorFlow for deep learning, Matplotlib and Seaborn for visualization, Scikit-learn for machine learning, and NLTK for text pre-processing. Exploring the dataset. This step involves inspecting and understanding the dataset, including its structure, variables, and data types. Data processing. This module is responsible for cleaning, transforming, and preparing the dataset for analysis and modeling. Visualization using Seaborn and Matplotlib. In this phase, data is visually represented using the Seaborn and Matplotlib libraries, aiding in data exploration and insights. Feature selection using formal data. This step involves selecting relevant features which are variables from the dataset for modeling, based on formal data analysis. Lexicon vectorizer. This module is responsible for converting text data into numerical format using lexicon-based vectorization techniques. Splitting the data into train and test. This step involves dividing the dataset into two subsets, one for training the model and other for testing its performance. Building the model. In this module, various machine learning and deep learning models are constructed. Logistic regression. It is used for binary classification tasks. LR is suitable for modeling and predicting binary outcomes. It is applied when the project involves tasks like sentiment analysis or binary decision making. Random forest. It is a versatile ensemble learning method capable of handling both classification and regression tasks. It is employed when the project requires robust performance and handling complex datasets. ADA boost classifier. It is an ensemble learning algorithm used to improve the accuracy of weak classifiers. It is useful when the project aims to enhance the performance of base models. SGD classifier. It is stochastic gradient descent. It is a linear classifier suitable for large-scale datasets. It is used when the project needs efficiency and scalability in linear modeling. KNN, which is K nearest neighbor. It is a non-parametric algorithm used for classification and regression tasks. It is applied when the project requires proximity-based predictions. MNB, which is multinomial naive Bayes. It is well suited for text classification tasks, particularly when dealing with the text data and multiple classes. It is used for tasks like text categorization and sentiment analysis. Support vector machine. It is employed when the project needs to find the optimal hyperplane for classification tasks, especially in cases with a clear margin of separation between classes. MLP, which is multi-layer perceptron. It is a deep learning architecture used for complex tasks where neural network with multiple hidden layers are needed, such as image recognition or natural language processing. Gradient boosting. Gradient boosting algorithms like XGBoost or LightGBM are used when high predictive accuracy and ensemble learnings are required for tasks like regression or classification. CAD boost, which is a gradient boosting algorithm designed to handle categorical features efficiently. It is used when the project involves datasets with many categorical variables. Voting classifier. This combines multiple models to improve prediction accuracy. They are improved when the model diversity can enhance overall performance. RNN with LSTM, which is recurrent neural network with long short-term memory. It is used for sequential data processing and it is well suited for tasks like text generation or sequence prediction. CNN, which is convolutional neural network. It is used for tasks including structured grid-like data such as image classification or text classification with convolutional features. Training the model. This phase involves feeding the data into the structured models, allowing them to learn patterns and relationships within the data. Flask framework with SQLite for sign-up and sign-in. This module is responsible for creating a web application using the Flask framework and integrating a SQLite database for user sign-up and sign-in functionality. Importing the packages. Similar to the first step, this module involves importing necessary libraries and packages which are dependent on the web application. Exploring the dataset. In this context, it initiates examining the data relevant to the user registration and authentication. Data processing. This step involves preparing and managing the user-related data for the web application. User gives input. During this phase, user provides input or interact with the web application. The given input is translated and pre-processed for prediction. This module processes user input, potentially translating them if necessary, and prepares them for prediction using the previously trained models. Trained model is used for prediction. Here the input is fed into the trained machine learning or deep learning models to make predictions or provide responses. Final outcome is displayed through frontend. The results from the model are presented to the user through the web application frontend, completing the user interaction cycle. For execution of the project, first we need to open the code folder. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file. This file contains the algorithm information and that will be loaded into the project code during runtime. And this is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells. This is the sign-up file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So we will copy this path and open the Anaconda prompt. Here using the cd command we will paste the copied path and this is used to change the current directory to the code folder's path. Now we will click on enter. So here the current directory is changed to the code folder's path. Here we will type python space app.py. This will compile app.py file and this command will perform a runtime check for any syntax errors or logical issues. Now we will click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is the localhost and the port number unless configured differently. So this is the local host and this is the port number. Now we'll copy this link and paste it in any browser. I usually prefer Google Chrome, so I will paste it in that. So here I'll paste the link and then click on enter. So this has redirected to the homepage of the project which is displayed in the browser, and this front end is built by using the Flask framework. Now we need to click on sign up. Here we need to fill all the sign up details if you are registering newly. I have already registered, so I'll directly click on sign in. Here I need to provide my credentials, which are my username and the password to log in. Now we'll click on login. So here we can see the text box where we need to enter the Bangla text. For that we will get the prediction whether the text is positive or negative. So here we will enter the text. So here I entered the text in Bengali. Now we'll click on predict. So the text is transformed to the English and it is predicted that the text type is positive. Now we will give one more message. I entered the message here. Now we will click on predict. It has translated into English and it is predicted that based on the given text type it is negative. Now we will give one more text. I entered the message here. Now we will click on predict. So it has translated in English and here we can see that the text type is positive. In this way we can give any Bengali text. For that it will be translated into English and then we will have the predictions whether the text is positive or negative. Conclusion. The project has successfully boosted access to online and technical resources for Bangla speakers, elevating language barriers and fostering digital inclusivity. The application of classical machine learning and deep learning algorithms proves to be proficient in processing, dissecting Bangla language data, facilitating improved comprehension and utilization of the language. By advancing Bangla natural language processing capabilities, the project empowers Bangla-speaking individuals to effectively navigate and utilize online materials, promoting digital proficiency.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.